Welcome to this WiseOwl Excel VBA tutorial. In this part of our series on writing SQL for Excel files, we're going to look at some text expressions. We'll begin by looking at how to concatenate values to form a larger string of text from multiple smaller parts. Then we'll have a brief look at how to convert between text and numeric data types. We'll use some text functions to look at how to replace characters in a string and how you can calculate the string length, and a quick look at how you can trim text to remove leading and trailing space characters. Towards the end of the video, we're going to look at how you can find characters within a string and use that to extract text from both the left, right and middle of a string. So let's get started. If you've been following along with previous parts of this series, you should be fairly familiar with the basic setup by now, so you may prefer just to skip to the next chapter of the video. If you haven't seen previous parts of the series, here's a quick idea of the basic setup. We have a macro-enabled workbook which we can use to run a query by clicking this button, and when we do that it's going to extract some information from a separate Excel file called Movies. The Movies workbook contains several different worksheets, each of which contains information related to films. I'm going to keep the Movies workbook open for the duration of the video, but you're welcome to close down the Movies workbook and all of the code will still work. I have both of these files stored in the same folder, and I'll drop a link in the video description so that you can download both files and follow along and write the code with me if you'd like to. A lot of the code that's in the text expressions workbook relies heavily on Microsoft ActiveX data objects, and that's not something I'm going to talk about much in this video. This series is meant to focus on the SQL side of things. So if you are interested in how the code works to connect to an Excel file in the first place and extract data from it, we have a separate playlist which covers that. I recommend starting with this video, how do I get data from a closed Excel file using VBA, if that's the part you're interested in. I should also quickly mention that some of the techniques we'll see in this video have been covered previously in a separate video in this playlist on text criteria and the like operator. That video focused on writing criteria in the where clause to return rows based on conditions. In this video we're going to focus on calculating new values from text, but there is a little bit of crossover between the two videos, so you may find more information in that one there as well. Just to show you the basic code, if I head back to the text expressions workbook, when we click the run query button, it triggers a subroutine called create SQL query, whose only job really is to construct the string representing our SQL query. That then gets passed into a separate subroutine called getQueryResults, and this one deals with establishing the connection to the Movies workbook, extracting the data into a record set, and this is where we use the SQL query that we've created to set the source property of the record set object. And then the rest of the code deals with creating a new worksheet and writing the contents of the record set into that sheet, and then tidying things up with some formatting. Just to show you what that looks like when we run the query, if I head back to the menu sheet and click the Run Query button, we extract a range of columns from the Movies workbook. As we'll be running quite a lot of queries in this video and generating lots of extra worksheets, we've also added a button which allows you to tidy up the workbook to delete everything except for the menu sheet. So if you head back to the menu sheet and click Delete All But Menu Sheet, you'll be left with just the menu sheet in this workbook. One of the simplest things we can do in terms of text expressions is to take multiple smaller pieces of text and concatenate them together to form one larger piece of text. A lot like we've done to create our select statements in the first place, in fact. So here we're using the ampersand symbol to concatenate these separate lines of code, which then get formed into one single large string at the end. We can use this same basic technique in our SQL queries. If I want to concatenate a phrase which would say the film title and then the literal text was directed by, followed by the director's name. So rather than showing the title and director in separate columns, we can have them both in a single column. To start with, I'm going to copy and paste the line which returns our film title, and then I'm going to paste that in a new line just before the from clause. Because this is a new column, I'm going to use a comma to separate this new column's definition from the previous one. And as you'll know from previous videos, you're welcome to place either the comma at the beginning of the line or at the end of the previous one. It's entirely your choice. To concatenate another piece of text to the end of the title column, I can use an ampersand symbol. Now again, if you're familiar with other dialects of SQL, such as Transact SQL in Microsoft SQL Server, you'd use a plus symbol to concatenate text. But with the provider we're using to connect to an Excel workbook, we must use an ampersand to do that. That makes it quite easy to get confused between the ampersands which are inside the double quotes, which form part of the SQL query, and the ampersands outside of the double quotes, which are used to concatenate our VBA strings. So, one thing to watch out for. Another thing to watch out for is which characters you use to delimit strings. I want to add the literal phrase, was directed by. If I were concatenating that in VBA, I'd need to wrap the phrase was directed by inside some double quotes. In our queries, our SQL queries in ADODB, it's much easier to use single quotes to enclose your strings within the query itself. So I'm going to use a set of single quotes. I'm going to make sure I put a space before the word was. If I don't include this space there, then the word was will be joined directly to the end of the film title, making things a little difficult to read. Then I can continue my phrase, was directed by, and then close the single quotes. Again, I'm making sure to leave a space here at the end of the phrase to make sure that the director's name doesn't just get included and attached to the end of the word by. And then I can concatenate another field, which again I'm just going to copy and paste rather than write out again from scratch. I can then assign an alias to this column by saying as, and I'm going to call it directed by. And then having done that, I can head back to my menu sheet, run my query by clicking the obvious button, and find that I get the film name, concatenated to the phrase was directed by, concatenated to the value of the director field. In the first example, we concatenated 3 separate strings of text, but it's equally easy to concatenate text with other data types such as numbers and dates. For the next example, I'd like to generate a phrase which says something like Jurassic Park won 3 Oscars. So to do that, let's head back to the Visual Basic Editor, and I'm going to start by copying and pasting the previous line we've just created into a new line in the same select list. I'm then just going to change the literal text was directed by to the word won, and then I'm going to change the field name we're selecting here from director to Oscar wins, and again I'm going to do that by copying and pasting. And then let's change the alias of the column, let's call it something like awards. So having done that, I can head back to the menu sheet in the workbook, click the run query button, and we'll see if I just change the width of some of these columns that it's equally simple to concatenate text with numbers as it is to concatenate text with other text. To complete this sentence, we now need to add the word Oscars to the end. So we'll end up with a phrase like Jurassic Park won 3 Oscars, Spider-Man won 0 Oscars, and so on. And that's going to work quite well until we get down to the film Pearl Harbor, where we'll encounter a problem. And the problem isn't the fact that Pearl Harbor won an Oscar when it's a terrible film, it's the fact that we'll have a phrase that says Pearl Harbor won 1 Oscars, which sounds and reads a little bit strangely. So we have a couple of different solutions to this, a fairly simple pragmatic approach and a slightly more complex but more satisfying one. Let's do the simple pragmatic version first of all. If we head back to the Visual Basic Editor, after we've concatenated the value of the Oscar wins field, we can then concatenate another piece of text, so I'll use an ampersand and then in some single quotes, starting with a space, I can enter the word Oscar and then in some round brackets, simply place the letter S. I can then close the round brackets and then close the single quotes, and if I head back to the menu sheet and run that query again, we'll end up with, again if I just change the widths of these columns so we can see this a little more clearly, 3 Oscars, so each one will read appropriately I think depending on the number of Oscars. It works, I suppose. It's the simplest solution, of course. I prefer to use either the word Oscar or Oscars in the appropriate context. So if the value of the Oscar wins equals 1, then I want the word Oscar, otherwise I want the word Oscars. So to do that, we can concatenate the result of an if function in the same phrase. So let's head back to the Visual Basic Editor, and then I'm just going to get rid of the round brackets around the letter S there. And then just in front of that string of text, I'm going to begin an if function. So I'll say if, open some round brackets. Then I want to check if the Oscar wins equals 1. Then I want to place in the phrase Oscar, or the word Oscar, followed by a comma, otherwise we'll place the word Oscars. and I can close the round brackets at the end of that to finish the if function. We've covered the if function in a previous video in this playlist, so just in case you need a reference for that, have a quick flick through the rest of this playlist to find the video on if and switch functions or conditional expressions. So having done that, we can head back to the menu sheet and then run the query again. And this time I think the result is a little more satisfying than last time. We get the appropriate word Oscars or Oscar, depending on the number of Oscars won. Now, if you're familiar with other dialects of SQL, such as Transact SQL in Microsoft SQL Server, it may surprise you that we can concatenate a number with a string quite so simply. In Transact SQL, we'd have to explicitly convert the Oscar wins value into a string first, or we'd have to use a function such as concat, which would perform the conversion for us automatically. Clearly, we don't need to do that here with the provider we're using to connect to an Excel workbook. But occasionally you will find it necessary to convert a number into a string of text, or vice versa. Just to show you the basic principles as to how that works, I'm going to add an extra column. I'm going to put this just after the Oscar wins field. So I'm going to copy that field first and then paste it in immediately below. I'm then going to wrap a function around this field reference called CStr, or convert to string. I can then open up some round brackets, close the round brackets after the reference to Oscar wins, and let's give this an alias. Let's call it wins as text. If I then head back to the menu sheet and run that query again, we'll find that I get a wins as text column with the exact same values displayed, but as you can clearly see, the values are aligned to the left-hand side of the cell, indicating that they're stored as text. And if I select any of these cells with the little green triangles in the top left-hand corner, I get the standard warning that the number in this cell is formatted as text or preceded by an apostrophe. Potentially slightly more usefully, we could attempt to convert text into a number. Let's try to do that for the film title column, although that doesn't appear as though we'll have much success if we attempt to convert Jurassic Park into a number. So let's add an order by clause to our query first, so we can see which films could be successfully converted from text into numbers. We'll add a new line to our select statement, so after the from clause we'll add an order by clause, and then we'll order by f.title in ascending order. Okay, so having done that, we can head back to the menu sheet and run that query again, and we'll see we have some films whose titles consist of only numbers, and you can see we've got this same green triangle symbol indicating that that number is stored as text. So Excel can clearly recognize that those values could be numbers. So should we want to convert them into numeric values, then we can head back to the Visual Basic Editor, and let's copy and paste the film title column, so we can drop that in on the next line of our select statement and replace the initial space with a comma. So we're going to use another conversion function to convert these values into numbers. We just have to pick the correct one for converting to the correct type of number. The conversion function names correspond to the data types in VBA. So if you're not sure what those are, there's a handy little reference page here on the Microsoft Docs website for the type conversion functions. So there's a list of all the functions, and then a little further down, a list of the data types and what ranges of values those data types can store. So we could get away, I think, in this case, if we have a look at the list of our film names, the ones that are numeric ones, the number 10, the number 2012 and the number 300, they could all happily fit within the bounds of the integer data type, so a maximum value of 32,767. So they're all whole numbers, and we could use CInt to do that. If we want longer numbers, then we've got things like CLNG for the long data type. And again, that's for whole numbers. And if we wanted decimal values, then we've got things like single and double. So let's see, I think we'll go with CInt for this one, just because it's the one that will use the least amount of memory to hold the values we need. So let's head back to the Visual Basic Editor, and in front of the film title column, I can say CInt, open some round brackets, close the round brackets after the reference to film title, and give this an alias, title as number. Now, of course, not every single film title can be converted into a number, but that's okay with this particular provider. Rather than generating an error, what we're going to see is that for any film which can't be converted into a number, we're going to see a null or a blank instead. So only those films which can be converted into a number get a value. If we wanted to exclude all of the films which could not have their titles converted into a number, we could add a where clause to the query. So one quick simple way to do that is back in the Visual Basic Editor. We can add a new line in between the from and the order by clauses and add a where clause. So let's say where, and then on the next line we'll begin a condition which says is numeric. So there's a function which will test if a value can be successfully converted into a number. So is numeric f.title. And then we can close the double quotes and concatenate a continuation character. And if we head back to the menu sheet and then run the query again, we'll return the list of only those films whose titles can be converted into a number. Just for the next example, I'd like to extend that condition to include all films which contain a number anywhere in their title. So to do that, I'm going to go back to the Visual Basic Editor, and then I'm going to change this condition completely. I'm going to say where f.title, and then I'm going to use the like operator to check if the film title contains a number anywhere in its name. So in some single quotes, with some percentage symbols wrapped around a set of square brackets and the phrase 0 to 9, or the character range 0 to 9. We've covered this in a lot of detail in the video on the like operator and text conditions or text criteria, so that's the video to reference if you're not sure what's going on here. So if any character in the film's title is a number between 0 and 9, that film will be produced in the results. So if we head back to the menu sheet and run that query again, we'll get a list of all the films which contain a number anywhere in their name. The reason I've brought back all of the other films which contain a number anywhere in their title is because there's one other function we can use to try to extract numbers from a string. The function's called val, and what val does is start at the beginning of the string and reads all of the characters up to the first one that it can't interpret as a number, at which point it will stop. So just to demonstrate how that one works, let's head back to the Visual Basic Editor, and I'm going to add another new columns definition below where we've converted our film title into an integer. In fact, I'm just going to copy and paste that line and paste it in, and then change the function from CInt to the function called val. And let's change the columns alias to say numbers at start of title. And then if we head back to the menu sheet and run that query again, we should find that any film which begins with a number provides us with the numbers at the beginning of that string. So we get 9 in 9 to 5 and 48 in 48 hours, but any film which title does not begin with a number returns a 0 as a result of the val function. So you can see from this example that the val function stops when it encounters the first character it can't interpret as a number. So in 20,000 Leagues Under the Sea it stops at the comma and returns the number 20. In 3:10 to Yuma it stops at the colon character and returns the number 3. And for films which don't begin with a number, it stops immediately and returns the value 0. There's not an awful lot we can do about this using the basic functions we have available. What we really need here is a regular expression, but that's a little beyond the scope of this video focusing on SQL, so we'll save regular expressions for another time. There is, however, one function we could use to help a little bit in cases like 3:10 to Yuma, where there's a specific character, a colon, that we could replace with an empty string, which would make the number 3:10 into the number 310. So just to demonstrate the basics of the replace function, let's head back to the Visual Basic Editor, and then just after the film title column, in fact I'm going to copy and paste that once again, and then start this line with a comma rather than a space, and then begin my replace function. So the first parameter of the replace function says what string of text you're looking for characters to be replaced within. So I want to replace characters within the film title. I'll follow that with a comma, and then I can say which character I want to replace. So that's going to be a colon character inside some single quotes, followed by another comma, and then which character or string of characters you want to replace the colon with. In this case, I want an empty string. So I'm going to open and close some single quote characters, close around brackets, and then say as film without colon. or colons I should say. That will replace every instance of a colon character in the film title. If I head back to the menu sheet and then run that query again, just so that you can see that we now get films with no colons in their names, so wherever those would have appeared, they are now gone. So if we pass the result of the replace function to the val function, for instances like 310 to humour, it will return the number 310 instead. So let's head back to the Visual Basic Editor, and I'm going to copy and paste that replace function. And then inside the val function, rather than saying f.title, I can paste in the entire replace function, not forgetting the extra close round bracket there. Head back to the menu sheet, run the query again, and now we get the number 310 rather than just the number 3. Let's move on and look at some of the other things we can do with the replace function combined with some other text functions. For the next set of examples, I'd like to switch which worksheet we're selecting our data from. So I'm going to comment out the query which selects from the film worksheet and then uncomment the one which selects from the role worksheet. If I simply head back to the menu sheet and run that query, we'll see a list of all of the actors, the character they played and the film they played that character in. Now in some cases the character has multiple names or multiple titles, separated with a / character. I'd like to return a list of all the films which have a / character, or all the characters I should say, which have a / character in the role column. So to do that we can head back to the Visual Basic Editor, and in the query we can bring in a where clause. So let's add a where clause, and then using the same technique we used to find a number in the film title earlier, we can check to see where the role column contains a / character. So we can use the like operator in some single quotes enclosed within percentage symbols, a / character, like so. Having done that, we can head back to the menu sheet and we can run that query again. And now we'll see all the characters which have multiple names. Most of the roles we've returned in this list contain just a single / character and therefore 2 separate names. But there are some examples where there are more than 2 names. If I scroll down towards the end of the list, just to quickly show you, there are some examples such as Wesley, the Dread Pirate Roberts and the Man in Black from The Princess Bride. So what I'd like to be able to do is find out how many names each role contains. And one way to do that is by replacing the / characters with empty strings, and then comparing the length of the strings of text, one without the / characters replaced and one with the / characters replaced. To do that we can use a function called len, and just before we do the replace example, let's show you how to use the len function to sort this list so that the longest role name appears at the top of this list. If we head back to the Visual Basic Editor, I'm going to include another continuation character at the end of our query and then add in the order by clause, and I'll spell that correctly. There we go. So order by, and then I can say len of r.role. So all the len function does is counts the number of characters in that string of text. I'm going to go in descending order this time so that the longest film appears at the top of the list. And if we head back to the menu sheet and run the query, we'll see the longest role appears there at the top of the list. Now let's use that same function to display the length of the role text. Let's head back to the Visual Basic Editor, and I'm going to copy and paste the role column name, paste that in immediately below, and then wrap the len function around the role column again. I'll then provide an alias so I can display a sensible name at the top of the column. Let's call this length of role. And then I can do exactly the same thing to replace the / characters and then calculate the length of that. Let's copy and paste the line we've just written and say length of role, but not just r.role. We're going to say replace r.role followed by a comma. I'm looking for a / character and I want to replace that with an empty string. And I'm going to make sure I close the extra set of round brackets for the replace function. I'll say length of role without /. Okay, so having done that, we can head back to the menu sheet And we can run that query and we'll see the difference in lengths when we've removed the / characters and when we haven't. So the next step is simply to subtract one value from the other and then work out the difference and make sure that we add 1 to the result, of course. If I subtract 54 from 55, that returns the number 1, but to give me the number of names in the role, I need to add 1 to the end result. So that's nice and simple. We could copy and paste our len r.role, and then before we say as length of role, let's subtract from that the length of the replaced version of r.role. And then at the end of that, we can add 1 and then say number of names or count of names or number of roles, something like that. Let's go for number of names. So head back to the menu sheet, run the query again, and that tells us how many names there are in that role column. Another basic function you'll find useful for manipulating strings is called trim, and this allows you to strip away any spaces which appear at the beginning or the end of a string, which is particularly helpful when you can't guarantee the quality of your data entry. Just to demonstrate how that might be useful, I'm going to tidy up my query a little bit. I'm going to get rid of my where clause entirely, and then I'm going to get rid of the 3 additional columns we've created using the len function. I'm then just going to change my order by clause to order by r.role in ascending order this time. So I'll strip away the len function and replace desc with asc instead. So sort the roles in ascending order, so alphabetically listed. However, if we head back to the menu sheet and run that query, it doesn't appear to be quite as alphabetically listed as it could be. I'm not quite sure why Emperor Palpatine appears at the top of our list in the role column. You might be able to spot, actually, if you have a quick look, you might be able to spot there is an additional space character sitting just at the beginning of these first 4 roles that have been entered. If you double click into the cell, you can see that that space character is sitting just there. So I would like to strip away that additional space character, and I can do that very simply just by adding the trim function to the order by clause that I've just created. So let's head back to the Visual Basic Editor. There are actually 3 different versions of the trim function I could use here. There's an ltrim function, which allows me to remove leading spaces or spaces at the left-hand side of the text. There's an rtrim function to get rid of spaces at the right-hand side of the text, or there's just a generic trim function which will remove spaces at both the beginning and the end of the string. So I'm going to use the generic trim function, make sure I wrap the role column in a set of round brackets, and then head back to the menu sheet, run that query again, and now we get the list properly alphabetically sorted with Emperor Palpatine sitting somewhere further down that list. We started the video by looking at how to combine multiple small bits of text to form a longer string, and for the final few examples I'd like to do the opposite of that. I want to look at how to break the actors' full names into their separate parts, for a first name, a surname, and for those actors who have them, a middle name as well. So to do that, let's head back to the Visual Basic Editor, and I'm going to start by looking at how to extract characters from the left-hand side of a string. So I'm just going to start by copying and pasting my act name field, and then I'm going to replace the space at the beginning of that with a comma, and then insert the left function. You may already be familiar with the left function, but just in case, there are 2 parameters. The first one is which string you're trying to get your characters from, followed by a comma, and then the number of characters you want to get from the left-hand side of that string. So let's say 4 for this example. We'll provide an alias, let's say as first 4 characters. And then we can head back to the menu sheet and run that query. And that will return, as suggested, the first 4 characters from the start of the actor's name. So that technique has worked quite well so far for people like John and Chris and Alan, but not quite so well for some other people in our list. So the next stage of the process is to work out the location of the character which separates the first name from the rest of the string. So in this case, the character is a space. I want to find the location of the space character in the actor's name, the first one searching from left to right. And to do that, we can use another function called InStr or InString. We've seen this function again previously in the video on text criteria, so just as a quick recap, let's head back to the Visual Basic Editor, and I'm going to add a new column to our select list, starting with a comma and then InStr or InString. The first parameter specifies which character you begin searching from. It's actually optional, but I'd like to specify that we search from the first character in the string. Follow that with a comma, and then refer to the actor name field, that's the string that we're looking in, followed by another comma, and then the character that we're looking for. So in this case, in some single quotes, we're looking for a space character. I can then close the round brackets and provide an alias. Let's call this something like position of first space. Close the double quotes and then concatenate a continuation character. And then if we head to the menu sheet, run the query again, it will tell us the character location of the first space found, counting from left to right in the string. So now we can simply combine these two functions to return the correct number of characters for each individual person. So to do that, let's head back to the Visual Basic Editor, and I'm going to copy and paste the first 4 characters line. And then instead of having the number 4 there, we're going to copy and paste the InStr function. So let's replace the number 4 with the InStr function, and let's call this one first name. Okay, so having done that, let's head back to the menu sheet and run that query. And we'll see we get a new column now that contains the correct number of characters to hold each person's first name. Now, of course, if you compare the number of characters we've just returned with the actual number of characters in the name, we return the first 4 characters to get John, but now we've returned the first 5 characters. So although you can't see it unless you double click into the cell, we have indeed returned that extra space at the end of the name, which ideally we would get rid of. And we already know how to get rid of that. We've seen the trim function or the rtrim function. So let's head back to the Visual Basic Editor, and then just to complete this example, let's wrap the trim function around the left function, close the extra set of round brackets at the end, and then if we head back to the menu sheet and run the query again, the results don't look any different, but if you double click on the cell this time, you'll find that there is no extra additional space at the end of the name. So things appear to be working quite well so far, but there is one small problem we haven't yet considered. What if the actor's name doesn't actually contain a space? Well, we do have a few mononymous actors in our list. Let's change the sort order of our query so that their names appear at the top of the list. If we head back to the Visual Basic Editor, we can copy and paste the entire expression we've just created, trim left InString, and then replace our order by clause with that function instead. Okay, so if you head back to the menu sheet and we run that query, we'll find all of the actors with a single name don't technically have a first name at all. To solve this problem, we could check if the result of the InStr function equals 0, and if that's the case, we can just display the actor's full name in the first name column. So to do that, let's head back to the Visual Basic Editor, and I'm going to wrap an if function around the combination of functions we've already written here. This is going to get quite messy if I try to write the entire thing on one single line. So just in front of the trim function, I'm going to write if, open some round brackets, and then close a set of double quotes, and concatenate a continuation character before taking this extra code down to the next line. And then I'm going to indent that code 1 space, open some double quotes, follow that with a space. The first parameter of the if function is the logical test you're performing. So I want to compare the result of the InStr function and ask if that is equal to 0. So I'm going to copy and paste that rather than write it all out again from scratch, and then check if the result of that equals 0. Then I'm going to close the double quotes and then concatenate another continuation character, and then at the beginning of the next line, open some double quotes, followed by a comma. Then I want to place the actor name value if that condition returns true. So I'm going to copy and paste r.actName, close the double quotes, and then concatenate another continuation character, and then at the beginning of the next line open some more double quotes, followed by a comma. One last thing I need to do, because I've opened a new set of round brackets for the if function, I need to make sure that I close the extra set of round brackets at the end of the expression there. But having done that, I can head back to my menu sheet, run my query again, and there we go. We've got everyone with a first name, including those actors who don't have a space in their name. Next, we can start working on calculating the last name of each actor. The starting point for that is working out the location of the last space in the actor's name. Now, for most actors, the location of the last space will be the same as the location of the first one. Most actors have just a first name and a last name. But for actors who have multiple names, let's just pick one of our characters, our roles, just to demonstrate this. Imagine there was an actor called Sue Lee Shelley who has a middle name. The location of the last space is different to the location of the first one. So I want to find the location of the last space, starting our search from the right-hand side of the string. And to do that, we can use a variation of the InStr function. We can use InStrRev or InStrRev, as it's abbreviated to. So to demonstrate how that works, let's head back to the Visual Basic Editor, and I'm just going to copy and paste the InStr function. There are a couple of basic modifications I'll need to make, but I'll paste this in just after we've calculated the first name for each actor. Okay, so we're going to change the name of the function first of all to say InStrRev. There is a parameter which allows you to specify the starting position, but this parameter does not appear as the first parameter. The first parameter is which string you're searching in, followed by which string you're searching for. And if you wanted to specify the start position, you type in another comma and then enter that value there. Now the default value is -1, which means it will start searching at the end of the string, which is exactly what we want. So I'm going to omit the last parameter altogether there. I'm just going to search in the actor's name for a space character, searching in the reverse direction. I'll modify my alias name here as well to say position of last space. And then I'm also just going to tidy up a little bit and get rid of that column which calculates the first 4 characters. That's completely pointless at this stage. Okay, so if I were to head back to the menu sheet and run that query, we should see that we get, for most people, the position of the last space and the position of the first space is identical. But if we get down far enough and find an example of somebody who has a middle name as well, like Andre the, you can see the position of the first space and the position of the last space are indeed different. So the next step is to return all of the characters from that position all the way to the end of the string. And the easiest way to do that is to use a function called mid. Let's head back to the Visual Basic Editor. And then after we've calculated the position of the last space, let's insert a new column beginning with the mid function. So we start by saying which column we're looking in. So of course, once again, that's going to be the actor's name. And then after that, we say which position we want to begin returning characters from. So that's the same as the position of the last space. So let's copy and paste that entire expression. And then there is an optional parameter after that which allows us to specify the number of characters to return. But if we omit that, it returns all of the rest of the characters through to the end of the string, which is exactly what we want. So at this point I'm going to close the extra set of round brackets and give this an alias. Let's call it as last name. Okay, so I need to close the double quotes and then concatenate another continuation character. And then we can head back to the menu sheet and run that query again. And now we should be finding that we get all of the characters to the end of the string to return the actor's last name. Now you might notice again that we've got this additional rogue space at the beginning, so we've included everything from the space character, and the solution to that is just the same as the one we've used multiple times already. We can wrap the trim function around our mid function to make sure that we don't include that additional space at the beginning. So we can head back to the menu sheet and run that query once more, and we'll return all of the actors' last names without the leading space. You probably noticed that for actors who don't have a space in their name, the last name column has returned an empty cell, which I think is exactly what we would want in this situation. The first name column contains the only available name, so the last name should be empty. The reason that happens, by the way, is because we're passing a value of 0 to the mid function to indicate the starting position of the string to return, and when you do that, the mid function returns an error. The way this particular provider works, when we're using AdoDB to connect to an Excel workbook, any errors in your column's definitions get replaced with a null or an empty cell. So we don't need to test if the position of last space is 0, then return an empty cell. That's what happens anyway. So what we need to do next is work out the middle names for any of our actors. And the technique we're going to use to do that is to use the mid function to start returning characters from the position of the first space. But then we're going to specify that the number of characters we want to return is equal to the location of the last space, subtract the location of the first space, and return that number of characters. So for Andre the Giant, if we subtract 6 from 10, we get 4. So we'll start at character number 6, return the next 4 characters, so we'll get the words the with that leading space character there as well. So to put that into practice, let's head back to the Visual Basic editor, and I think we can get away with copying and pasting a big chunk of our previous column here. Actually, let's just copy the entire thing for the last name column and then paste that in below. I'm going to change that to say middle names, and then the starting position for the mid function isn't the position of the last space, it's the position of the first space. So I'm going to change that to say InStr rather than InStrRev, and I'm going to indicate that I want to start at the first character. Again, that's the default anyway, so I don't need to do that part, but I've done it anyway, just to be consistent with my previous InStr function. The next thing I need to do is say how many characters I want the mid function to return. So I've specified that I want the actor name from the actor name starting at that position, but now I want to specify that the number of characters I want to return is equal to the result of in-string reverse subtract the result of in-string. So in between this set of round brackets, the set of round brackets which closes the in-string function, just after that position there, type in a comma. Then I'm going to copy the in-string reverse function from the previous line, and I'm going to paste that in, and then I'm going to type in a space and subtract from that the result of the in-string function. So I'm going to copy and paste that from the same line. This is once again getting very messy, so I'm going to tidy this up in just a moment. So having pasted that in, I'm going to break my trim and mid functions, I think. So I'm going to keep trim and mid on the same line, close a double quote characters there, and then concatenate a continuation character, and then set the first parameter of the mid function to get characters from the middle of the actor name. I'm then going to close some double quotes. I'm going to also add a space there just to make things line up neatly. Close the double quotes, concatenate a continuation character, and then on the next line begin with a comma and then set the starting position using the in-string function, close the double quotes, and then concatenate another continuation character, and then the final part, the number of characters to return, is the position of the last space minus the position of the first space. And hopefully I've closed the enough round brackets there as well. We'll find out shortly if we head back to the menu sheet, if I can find that. In fact, I'm going to tidy up my workbook by deleting all but the menu sheet, and then we can run our query and we return a list of all the actors, first names and last names, and for those actors who have them, the last names as well. Even if that doesn't, sorry, the middle names is what I should have said there. Even if it doesn't quite make sense for everybody, we get whatever sits in between the first and the last space in their names. So there we go, there's some basic techniques you can use to manipulate strings in your SQL queries. In the next video in this series, we're going to move on to look at how to group and aggregate data. So I hope you're looking forward to that one. Thanks very much for watching as always. See you next time.